So they want us to use matrices to solve these systems. So you can set them up similar to other Newton problems. Actually, it's probably first best to make equations. The cost of one shirt, we'll call that X. The cost of one sweater, we'll call that Y. And they say 5 shirts, the cost of 5 shirts plus 5 sweaters is $205. That's the first part of that first sentence. And then 6 shirts and 9 sweaters, that cost adds up to be $294. So as a matrix, looks like this. Just put the coefficients and make sure the letters are stacked. Usually we put a bar to separate, the constants and what it should equal. That's not necessary when you type in matrices in Newton, but that's typical notation. So there it is as a matrix. And what you want to do is you want to get this in row reduced echelon form. You want to ideally have ones in the diagonal and zeros elsewhere. That way you can clearly see what X equals and what Y equals. So that's our goal. And to do that, you can add 2 rows, you can subtract 2 rows. You can multiply a row by any number you want. So, or you could swap 2 rows. Those are the 3 big operations. Addition, which includes adding or subtracting. You could multiply or divide a row by something. That's the second group of operations, and the third group is swapping them. So, since I'm looking for ones on the diagonal, I'm going to you should start in the top left and try to get a 1 up there. I'm going to multiply this row by 1/5, and if I do that, then I have 1 in the diagonal like I was looking for. And 205 divided by 1/5 gives us 41. And I guess while we're at it, no, that's good. Let's just do 1 at a time. Now, the next step, after you get 1 in the top left diagonal, when you're trying to get in row reduced echelon form, you want to get a 0 down here. That's like your pivot column. You're going to use that to make all the other columns have zeros except for the one where you want. So the next step is to get a 0 down here. So to make that happen, I'm going to take row 2. So I'm going to symbolize that with R sub 2. And I'm going to add -6 times row 1 to it. So when I do that, that means row 1 is staying the same. So I actually got to the end of this problem and I realized I made a mistake back here. So when we did 205 divided by 5, that should have made 41. I dropped the 1 there. That messed everything up in my calculation. So, okay, doing this calculation again. Remember, the whole reason we're doing it is that we can have a 0 here, like we were saying before. So row 1 stays the same. And now we're taking row 2 and we're adding -6 times row 1. So -6 plus 6 makes 0, just like we wanted. -6 times 1 is -6. -6 plus 9 is 3. -6 times 41, I'm just going to remember that's -246. So 294 plus -246 is 48 here. Okay, so now we have a 1 and a 0. We want to have a 1 and a 0 here, okay? So we want to get that 1. That's our pivot. So if you make 1s in the diagonals, you can use that to make everything else become a 0 really quickly. So multiply that entire row by 1/3. 0, 1, and then let's see if I can do this right this time. That's 16. So we have Y equals 16 here. So 1 sweater is $16. And you actually don't have to keep going with matrices here. This is X plus Y equals 41. That's what the top row says. We just found out that a sweater is $16. So if you plug that in and solve for X, the sweater is $25. The shirt, I'm sorry, X is $25, the shirt. Same type of thing with this problem. We'll call this X, Y, except this one we have 3 variables, so X, Y, and Z. 6 pencils, 7 markers, 8 erasers made $15.75. Then 6 pencils in the second sentence, 6 pencils, 8 markers, and then 5 erasers made $16.75. And then 5 pencils, 5 markers, 7 erasers. Oh, why am I putting Y's here? These are Z's, sorry. 7 erasers made $11.75. So as a matrix, we've got 6, 7, 8, 1575. And the decimals are going to get kind of annoying there. 6, 8, 5, 1675, and then 5, 5, 7, 1175. You could do this the normal algebraic way to get x, y, and z, but with 3 variables, it is probably easier to do a matrix. Okay? Because if you remember doing this system of equations in the previous math class, it would take a while to do it algebraically. So a matrix is a little bit quicker. Remember, the first goal is to get a 1 in the top left position. So I'm going to take row 1 and I'm going to add -1 times row 3 to it. And the reason I'm doing that is because I know -5 plus 6 would give me 1 up here. And note how we're just changing 1 row at a time. All the other rows are going to stay the same. So -5 times 5 makes -5. Sorry, -1 times 5 makes -5. -5 plus 7 makes 2. -1 times 7 makes -7, -7 plus 8 makes 1, and then this and this. That's basically 15. You could have rewritten that as just row 1 subtracted by row 3. That's the same thing. So that's 4 here. Ooh, no more decimal. That's good. Then we'll copy down the rest. Okay, now we want the rest of these to be zeros. Since we've already got our pivot, though, that's going to be a pretty quick process. I'm going to kind of break convention, though, to save my handsome writing here. I'm going to modify 2 rows at the same time. I'm going to take row 2, and I'm going to add -6 times row 1. The reason is because -6 times 1 is -6. -6 plus 6 makes 0, like I want. And then row 3, I'm going to take -5 times row 1. So if we do that, row 1 stays the same. And now in red, row 2 has been modified. -6 times 1 is -6. -6 plus 6 makes 0. -6 times 2 is -12. -12 plus 8 is -4. -6 times 1 is -6. -6 plus 5 is -1. -6 times 14 is -24. -24 plus 1675 is -7.25. So the second row has been modified, and usually teachers say do 1 row at a time, but if you get really comfortable with it, it's okay to modify 2 at one time, especially with color like this. But, all right, row 3 is -5 times row 1, so that makes 0 here. -10 plus 5 makes -5. -5 times 1 is -5. -5 plus 2 is, and then -5 plus 7 is 2. And -5 times 4 is -20. -20 plus 1175, what is that? -8.25, but I messed up on the previous question, so I'm just going to double check that. When I make videos, sometimes it's hard for me to do that mental arithmetic. Okay, that checks out. So, first column is good. It's in row. It's getting towards row reduced echelon form. We got 1 in the top right column, 0s elsewhere. So my next step would be to get a 1 here, because that's my pivot. That's what I use to make everything else become 0. So I'm going to take this row and multiply it by -1/4. So everything else stays the same. We've got 1, 2, 1, 1, 4 for the top row. This row, because we have a 0 here, that doesn't mess up our row reduced echelon form. -1/4 times 0 is 0. -4 times -1/4 is 1, like we wanted it to be. -1/4 times -1 is 1/4, a positive 1/4. And -1/4 times -7.25, that's going to be positive. It's yucky though. Should it be yucky? Yeah, because on the denominator, 1/4 times, yeah. So 7.25 times 0.25 gives us 1.8125. And then we'll keep everything the same in the bottom row. So good penmanship is pretty key here. It's hard to write with this mouse, but if you're doing this on paper, just do it carefully. Let's do a little cheating together. Let's take row 1, and we're going to add -2 times row 2. And then row 3, we're going to add 5 times row 2. I'm doing that because I'm focusing on making these be zeros, okay? So row 1 doesn't get modified because of our earlier work of making sure these are all zeros. So the 1 doesn't get modified. I should be specific there. The rest of the row is going to get modified because -2 times 1 is -2. -2 plus 2 makes 0. -2 times 1/4 is -1/2. -1/2 plus 1 makes 1/2. Or 0.5 if you prefer. Either one. -2 times all that stuff is -3.625. -3.625 plus 4 gives us 0.375. Getting closer. Row 2 stayed the same. And then we got row 3. It's being modified, but 5 times... Oh yeah, 5 times 0. Did I mess up this one? Why did I write that down? I did mess this one up. No, that's good. We're good. That was the one that stayed the same. Okay, so that's good. Okay, we're good. I'm sorry, I was just double checking. So row 3, we're going to add 5 times row 2. So 5 times 0 makes 0. 0 plus 0 makes 0. 5 times 1 makes 5. 5 plus 5 makes 0, just like we wanted. 5 times 1/4 is 5/4. 5/4 plus -2. Let's just use decimals. Plus -2. I didn't put my negative sign. So we got 5 times 1/4 is 5/4, or 1.25. 1.25 plus -2 is -0.75. And then we have 5 times 1.8125. We're going to add that to the -8.25. That was in row 3, so that's 0.8125. And then we're looking for 1s here, right? This is good. 1s in the diagonal, 0s elsewhere. 1s in the diagonal, 0s elsewhere. We need 1 here. So that's -3/4. We need to multiply this by -4/3. Okay, because 4/3 multiplied by 0.75 gives us, if I would have put the negative sign in there, gives us what we wanted, okay? And that'll be it. That'll unravel everything else. We don't have to keep going, okay? Keeping everything the same, except for the last row. So this times this makes 1, like we wanted, and now we got to do -4/3 times 0.8125. So, oh man. I messed up something because that shouldn't be negative. So let me look. I found my mistake. I copied a negative sign that shouldn't have been there. If you go back to our steps, you'll see that the 2 in the bottom left corner does not have a negative sign. So that would make this be positive. That'll change this all together here. This is going to be, so we're probably going to not have to multiply by that. When we were trying to compute this cell here, that was supposed to be 5 times row 2, so 1.25, right? 5 times 1/4 is 1.25. 1.25 plus 2 makes 3.25. And now, I mean, we don't have to necessarily do row reduced echelon form. This says 3.25z, because it's the third column, that's our z column, equals 0.8, smiley face, 0.8125. So if we do 0.8125 divided by 3.25, it gives us z is 0.25. And now you can use that to plug it back in. That's not supposed to be 1/4, is it? It is, yeah. Plug that back in everywhere into the other equations. Like let's plug this back into the second row. So 1y plus 0.25, that's 1/4, times our 0.25, just a coincidence that those are both the same. That should equal 1.8125. And if you solve for y there, what did I do wrong? 0.25 times 0.25. 1.8125 subtracted by that gives us 1.75, so $1.75 for y. And then plug that back in to find out what x is into this top equation. That's nice and quick. That says x plus 0.5z equals 0.375. It's really poorly written, but that's 0.375. 0.25 times our 0.5. I plugged in 0.25 in for z just like we did before. 0.375 subtracted by that gives us x is also 1/4, 0.25. So there's our solutions. Okay, so once you get one answer like we did here, then you can plug it into the next row to get the other variable. And then you can, if you need it, you can plug those two to find out the third variable.